Video number 5 of our chapter, we're going to discuss confidence intervals for the difference in two sample means.
Now, back in the day, this is the way that we would do a confidence interval for one mean. We would take our sample mean, that would be our point estimate, and we would add and subtract a certain margin of error. So we dealt with t-scores because typically we did not know what the population standard deviation sigma was. So we replaced it with s in this case. So we had to use a t-score and we had to use inverse t, which some of you, I had to give you that program on your TI-83. The rest of you should already have it built into your calculator in the 84s. But here's what our confidence interval formula is going to look like for two means. Okay, instead of just having one x bar, we're going to subtract our x bars. Plus or minus, we still have a t-score. But now, this should look very similar to what we just did in the last video. We need to square our sample standard deviations, or if you know sigma, go ahead and use sigma. Square those and divide by our sample sizes for each of those, and we need to take the square root of all of this sum. Okay, so this is what we're going to be using now. Now, in terms of degrees of freedom for our t-score, you have two options. You can use this formula, which is called the Satterwalthy formula. You can certainly knock yourself out and do this. Actually, the calculator, if you were to do a confidence interval for the difference between two means, this is what the calculator uses. And a lot of the times you're going to end up with a degrees of freedom number that may not be a whole number, which is an interesting case here. You may end up with like 57.34 degrees of freedom, which is a little weird. But that's what happens with this crazy formula. Now, if you don't really want to do this, which I absolutely would not blame you, could you imagine doing a proof for this? That'd be ridiculous. Here's our second option, which is going to be the much more sane option to use here because it's a lot easier. For degrees of freedom, we're going to pick the smaller of either the first sample size minus 1 or the second sample size minus 1, whichever one is smaller in value. Now, if it's a tie, just take that number. But if one of them is smaller than the other, then use that as your degrees of freedom. Okay? And as I mentioned here, with this option, the resulting confidence interval has a margin of error as large as or larger than is needed for the desired confidence level. So all of this really means is using this conservative degrees of freedom value, instead of our confidence interval maybe going from here to here, like maybe this is option 1, this is using the Satterwalthy formula. Maybe this would be the confidence interval we would get from it. Versus if we just pick the smaller sample size minus 1, then maybe our confidence interval, let me get a little bit more direct here, let's scoot this over. Maybe instead of it being from just here to here, maybe it's more from here to here. It's a little bit wider, but it's not going to be like too much wider, okay? You're going to add a little bit more width here to your ends, but it's okay. It's honestly going to be all right. And we'll talk about maybe when it's maybe not okay, maybe when you want to go and maybe do option 1, okay? So conditions. Hey, they're pretty much the exact same crap we've been dealing with all this time. Except again, instead of saying a normal distribution, we're going to be dealing with a t distribution. All right? And central limit theorem still applies, but both of our samples have to be greater than or equal to 30. And if either sample size is less than 30, then that's when we're going to have to break out the box plots. Okay, and we're going to have to look for strong skewness or outliers. If we don't see those things, we may proceed with t procedures. If we do see one of those things, we say the sampling distribution is not normal or not t, therefore you cannot proceed with the confidence interval. So here's the example we're going to look at. Get rid of that. Do plastic bags from Target or plastic bags from Walmart hold more weight? A group of AP Stats students decided to investigate by filling a random sample of 5 bags from each store with common grocery items until the bags ripped. Then they weighed in grams the contents of items in each bag to determine its capacity. So here are 5 Target bags, and this is how many grams they could hold before they bust. And then here are 5 Walmart bags with their contents. So construct and interpret a 99% confidence interval for the difference in mean capacity of plastic bags from Target and Walmart. So I went ahead and did a little bit of work for you. Really what I did is I put my Target numbers into list 1 and my Walmart numbers, not 4, into list 2. And then I did some one variable statistics for list 1 and for list 2. Actually, you can do 2 variable statistics, which is right below 1 variable statistics. And first it will give you all of your Target information. And then if you keep scrolling down, then it gives you all your Walmart information. So you could do that if you want to, instead of doing 1 variable statistics twice. It's up to you. But here's the mean amount of weight that Target bags could hold with the sample standard deviation, and there's my sample size. And here's the mean amount of weight Walmart bags could hold with its standard deviation and its sample size. Okay. Now, if we just casually look at these numbers here, you might go, yeah, I mean, look, Target bags can hold what, about 3,600, 3,500 more grams on average per bag? That's true, but we are also dealing with a relatively small sample size of just 5 each. So maybe that 3,500 difference just happens to be a fluke with these 5 bags each. We don't really know. So part 1, we need to check conditions for a confidence interval. Are we dealing with random bags? Well, it said specifically random sample of 5 each, so that condition has been met. Independent, we need to check the populations here. Now really, the populations are going to be all Target bags and all Walmart bags. And can we assume that there are more than 50 of each of those types of bags? Yeah, there's definitely going to be more than 50. So we may calculate standard errors. Now normal, T. Now, number 1, are all bags known to be from a normal distribution? No. Do we have a big enough sample size that we can use the central limit theorem? No. So we're going to have to make box plots of our data. So here's what the box plots should look like. Now you can look at them individually, or what you can do, when you do stat plot and you go to plot 1, turn it on, select box plot, and do list 1. And then go back to stat plot and do plot 2, turn it on, do box plot, and do list 2. And then go to graph, and then zoom 9 for zoom stat, and it'll give you both of them together, okay, on the same screen. Now again, if we look at these 2 box plots, here is our Target box plot and here's our Walmart box plot. We can really tell that really all of our Target data is pretty much above the best even Walmart bag here. There's kind of a tie here. The min of Target is Walmart's best. So it's really looking like that there is a difference, but we're going to have to show that statistically. So calculations. Here's that lovely formula I gave you earlier. And now we're going to plug in our numbers. So here is the mean of our Target. Here's the mean of Walmart. Okay, so I'm calling one Target, 2 Walmart. And the reason why I did that was so that I would end up with a positive difference here. And again, you could go the other way. And then here are my numbers for the standard deviations. And keep in mind, you have to square. There's really a hidden square back behind here. Square those. And then the t, we're going to have to use inverse t to get this number. And since we are doing a 99% confidence interval, that means that there is 0.005, half a percent in the tail. So we have to do inverse t 0.005, comma, degrees of freedom, which I said you could use that crazy Satterwaffe formula, or just take the smaller sample size minus 1. Well, both of them are the same, so we would have 4 degrees of freedom. And that should give you a t-score of 4.604. So this is saying how many standard deviations, and this is a standard deviation right here, we can really do 4.604 of these above and below whatever this difference ends up being. So now let's get some values in here. So here's my difference. This is my difference point estimate from this. And then this is my margin of error. All of this ends up being this number. So now if I add and subtract that, at the subtracting part, I get all the way down to a negative 1380.1 difference, all the way up to an 8563.7 difference. Now if I use my calculator, This is the confidence interval I get. I get all the way down to negative 100.9, which is, I mean, more than 1,000 difference here. And then all the way up to 7284, which is, again, more than 1,000 difference here. Okay, so there is somewhat of a difference here. In terms of the grand scheme of things, this whole width is what, 1,300 plus 8,500. We're almost at like 10,000, basically, a width of 10,000 grams. And this is going to be more of a width of 400? So 7,400 versus 10,000. Yeah, it's about a 25% reduction in the width of the confidence interval. That does seem like a pretty big chunk there. Now our conclusion, we are 99% confident that the true mean difference capacity of plastic bags from Target and Walmart, and then I might want to throw in here respectively, because that is how I subtracted Target and Walmart, or you need to say, if you don't say respectively, Target minus Walmart to signify how you subtracted, is this between this and this grams. Now, does our interval provide convincing evidence that there is a difference in the mean capacity? Well, if there was not a difference, then we would expect 0 to be in our confidence interval. And hey, what do you know? 0 is between these two numbers. So since the confidence interval includes 0 grams, then we cannot conclude that there is a difference between the capacity of the two stores' plastic bags. Now you might be wondering, but Mr. G, that seems like crazy talk, because if we looked back at these box plots, I mean, the whole Target box plot was above the Walmart box plot. Why in the world did it come out in the end that we cannot conclude that there is a difference between the two? Well, I would say the one main reason is we had a very small sample size, again, of 5. What if we had taken, 30 plastic bags from each and did this, or 100 plastic bags from each? Then that means our margin of error would be much smaller, and our confidence interval would really shrink in in towards itself, basically, before it's that difference between that difference value. So then perhaps maybe 0 wouldn't be in there. So one strategy here, one lesson would be to use a larger sample size. 5 really isn't a whole lot to deal with here. And notice, let me jump back, using our technology confidence interval, 0 is still inside here. So we would still make the same conclusion. Now, let's say, for instance, let's play a little what if. What if our confidence interval had been like negative 3.5 up to like 10,000.7? And then we're asking, is 0 in this confidence interval? It's barely in there. So let's say this was done with option 2, and that's our confidence interval. You might really want to check out what is the proper confidence interval, because 0 might not be in it, because 0 is very close here, and there's a good chance 0 wouldn't be in the confidence interval using the proper degrees of freedom. So that's when I would recommend maybe checking out the option 1, even though it is a crazy, crazy degrees of freedom formula. Now here is the problem I would like you to do and bring to class, and we will go over together. So that is all for video 5. We will see you at the conclusion of video 6.